Hey there, and welcome to my channel. In this tutorial we are going to talk about how to design a steel structure using ETABS software. Okay, so I will go to the new module and will use built-in setting width. Okay, display unit will be metric standard international, and steel section database is EISC 15, the latest version. And still design code is also 360 to 2016, and also American Concrete Institute 318 2019. Okay, afterward press OK. And this quick templates, I will do not bother about uniform grid spacing. Okay, and I will select a number of stories to be 5, and typical story height should be 3.3, and the bottom story height will be 3.5. Afterward I will press blank and will press OK. Now I will go to the edit. I will add grid lines. Okay, edit stories and grid lines system. I will select grid system and will modify show grid system. I will use display grid data as spacing and will go for quick start new rectangular grids. I will use number of grid lines in x direction will be 5, and same as for y as well. Okay, and spacing of grid lines in x direction will be 6 and 6. Okay, and this will be the labeling. Afterward I will press OK. Look here, this is the grid data about x-axis and also about y-axis. Afterward I will just press OK. So we have created the grid lines. Okay, this is the plan view, this is the 3D view. Afterward I will go here to define the material properties. I will modify 60 case high as a rebar reinforcement. Okay, afterward, so the material type will be rebar, and I will not change these values as software is going to adequately choose its values correctly. Afterward I will press OK and OK. Now I will go here for define frame sections. I will go here to import new properties and will choose here steel flange section. I will select here W8 and will go here up to W10 last. Here I will select these. OK, afterward I will press OK, as these flanges will be used for secondary beams. Now I will again go here. I will just press OK this time, and I will go again here to the frame section. I will import new properties. We'll give a steel flange section. We'll give us this time W14 up to W18 as for primary beams and also for columns. Okay, I will go here. W14, I will hold the shift. Okay, and we'll go up to W18 last. Here, afterward press OK. So this will be for columns. Okay, and will press OK. Now I'm going here to the define frame section, okay, and I will add new property as a auto selection, okay, auto select list. So I will use auto beams, okay, auto primary beams, okay. So I will use auto selections and I will select these available imported sections, so the software is going to adequately choose one of the property which is economical and suitable and adequate for the design and analysis procedure, okay. So I will use the auto primary beams here. Auto selected type will be as a still, okay, and auto select option here I will choose the sections here from 14 to 18 as a primary beams, okay, from W14, okay, from W14 here up to W18 last. Okay, I will remove this one. W14 here up to W18, okay. I will add these sections at select list will be used for primary beams, okay. So the software is going to choose adequate beam section, okay. So afterward I'll press OK. So I have defined and add new property for primary beams. Now we'll add new property for auto select, okay, auto select for secondary beams, okay. I will use auto select design type will be still, okay. So this time I will use W12 from W12 up to W10, okay. I will add and will press OK. So I have added two primary beams and two secondary beams. I will add new property for auto select list, okay, auto columns. So still, and I will use here from W14 here. I will use from W12 up to W18, okay. Where I will use W14 here, W14 up to 18, add and press OK. So look here, to select for columns, primary beams, secondary beams, okay. Afterward I will press OK. So I have defined frame section, okay. Now I will define here deck section, which is used as a slabs for steel structures. I will add new property deck, okay. So the material will be 60 here and also 60. So and I will do not change other properties. It is okay. I will press OK. So make sure to delete this extra, and also I will repeat once again, the deck is used as a slab, okay, for steel structure. Okay, so the deck is used to distribute the load, okay, as working as a distribution option, okay, to distribute the load to beams, columns, and to the footing. Okay, afterward I'll press OK. So now I have defined material properties, frame sections, and deck, which is working for distribution load. Okay, now I will come here for the load patterns. I will define earthquake X direction, okay, seismic. The code is American Society of Civil Engineering 716, odd new one, X negative, the same code. I will use earthquake Y direction, okay, and earthquake Y negative direction, okay. So, and also wind X, I will change here to wind, and American Society of Civil Engineering 716, and also for wind Y, the same American standard, okay. So I will come here to do some modification. I will choose here only X directions plus eccentricity, and I will uncheck others, okay. So, and I will use here SS value will be 1.15, and also it's 1.51, and the side class will be B, okay. The time period will be program determined, okay. So, and here the response modification factor will be 6.5, and our strength factor is 3. Deflection amplification will be 5.5, and also importance factor is 1. Afterward I will press OK. The same I will do for earthquake X negative direction, okay. I will select here X directions minus eccentricity, and I will check others, uncheck others, okay. And SS value will be 1.15, okay, as the seismic coefficients, okay. And here 0.51, the site class will be B, and also the period will be program determined, and response modification factor or R factor will be 6.5, okay, and 3 same, okay. And I will also modify here for earthquake Y positive, okay. I will just check Y directions plus eccentricity, okay, and the seismic coefficients will be 1.15 and 0.51, okay. The site class will be B, and also R factor will be 6.5, okay, and the others will be the same, and press OK. Earthquake Y negative directions, okay, modify. I will check only Y minus eccentricity, okay. I will change here the seismic coefficients will be 1.15 and also 0.51. The site class will be B, and here the R factor will be 6.5, okay, others will be the same. Afterward I'll press OK. Come to the wind X directions, modify lateral load, okay. Exposure from extents of diaphragm will be 100, okay. Wind speed, I will use exposure type will be B, okay. And I will select arrange exposure height will be from 1, okay. So, and also wind pressure coefficients will be program determined, okay, and press OK. Come to the wind Y, modify lateral load, exposure wind speed will be 100, and the range will be from story 1. up to story 5, okay, and press OK. So I have done all the modifications, okay. Only I will add here the cladding load, which is used for wind, okay. I will use the super dead, okay, as a cladding, okay, and I will add only. So afterward I will press OK. So now I will come here and will select quick draw columns, okay. I will select here column, so I will use auto columns, okay. I will come here to the draw panel here, select all stories, okay. Now I will draw columns, so columns will be drawn one by one, okay. So if you want to change its angle, we will see afterward. So like I will select this one, I will come here. If I want to change its angle, I will change to 90 degree. So in this side will be 90 degree. Okay, here I will again change the angle to 0. Okay, I have drawn all the columns, okay. Now I will draw beams, okay. I will select here, I will select here, add to primary beams, okay. Add to primary beams, okay. Now I will select all stories here, and I will draw primary beams, okay. I'm just working in one story, but it's going to apply for all stories, okay. As this story is as a master story, story 5, okay. So I'm working in master story. The same changes will be placed for other stories as well. Okay, I will draw all the beams. Okay, I have drawn the primary beams, okay. Now I'm going here, will select quick draw secondary beams. I will come here and will select as a secondary beam, okay. So the moment release will be pinned, okay, and the number of beams will be 3 in each bay. Afterward I will draw here, 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 and all the secondary beams, okay. So I have drawn the secondary beams as well, okay. So okay, now we will draw the deck, okay. Here for still structures I will select deck, okay, and I will select here and will go in clockwise direction, okay, and press all the points here, the grid points, and I will go back to the initial point. Okay, all the decks will be drawn for all other stories as well. Okay, so as it is behaving working as a one-way slab, okay, so for load distribution it is showing like this sign. Okay, so now I am going to draw the exterior cladding for wind load applications. I am going here to draw and will come here to the auto draw cladding. Okay, so I will select use floors and will press OK. Okay, the exterior claddings for each and every floors has been drawn. Okay, look here. From all sides. Okay, so these cladding have no mass and stiffness. Okay, only this cladding is used for wind load applications. Okay, if you want to just go here to the elevation. Okay, so like look here, I will go here to the elevation and we'll select here to the 3D. Okay, when I select here and will press right click. Okay, look here, there is no area or stiffness. Okay, it is only used for wind load application. Okay, it have no stiffness and area or mass. Okay, in the next step I will go here. Okay, I will apply the gravitational or dead live load. Okay, I will select the deck. Okay, for all stories. Okay, I will come here to shell load uniform. Okay, dead load 1.44 kilonewton by meter square, apply. Okay, so and also select the deck again and go here, assign shell load uniform, and this time live load 1.53. okay, the gravity, apply. Okay, so if you want to confirm, come here, dead and live load has been applied. Okay, for other stories as well. Okay, yeah, in this step we are going to apply the wind load. I will come here to set the local axis. Okay, so I look here, the local axis, x directions, y directions, and z vertical axis. Okay, so like here we will have in these directions like x positive and x negative. Okay, and same as for y positive and y negative. Okay, so like look here, it will be y x negative. So I will come here to the elevation view. Okay, and I will select this direction. Okay, then I will come here to the assign shell load and wind pressure. Okay, so and wind x-axis. Okay, so like the CP value or coefficient, wind pressure coefficient will be negative 0.8. Okay, and windward these directions. Okay, as this x-axis directions, it is local axis is opposed to the direction of x-axis. Okay, that's why its value will be negative. After that, apply. Okay, I will go here. Okay, to this side y-axis and another side I will go to this elevation. Okay, I will select this cladding. Okay, this side I will go to the assign shell load. Okay, wind pressure coefficient. Okay, so this time will be wind and its value will be negative, okay, negative 0.8, because it is local axis is opposed to the directions of y-axis, okay, from this side, and it is windward. I will press apply and okay. Now I will come here to another side of the y-axis, okay, 5 elevation view, okay. I will select this cladding and I will go here to the shell load, wind pressure coefficient, okay, wind, and this time it is positive 0.8 and leeward from this side, okay. Apply, okay. So we are successfully applied the wind pressure about x-axis windward and x-axis leeward and y-axis windward, these directions, and y-axis leeward, okay. To confirm the wind pressure applied or not, we will just press in this cladding and we'll select right click, okay. It is showing, so the load pattern and wind y has been applied as a leeward, okay. So now we have successfully applied the wind load, okay. Now I will go here to this option and will uncheck the local axis, okay. So like here is unchecked, I will uncheck for this one as well, okay. Local axis uncheck, apply, okay. So consider that, so we will do not apply diaphragm, okay, the diaphragm to these floors, to the each story or the floors, because we are using here deck systems, and in the deck systems there is no need to use diaphragm, okay. So now I will go here to the define and load combination, okay, our default design combo and steel frame and composite beams, okay, and okay. So I have added the load combination. Afterward I will press OK for steel structure. Now we have completed all steps, okay. So I will come here to the plan view. I will select one story. I will delete this deck from the base, okay. I will select and will delete. I will fix this base, okay. Sign joint restraints fixed, apply, okay. So this story first, second, third, fourth, fifth and sixth, okay. So now we have completed all other steps. Only I am going to define, okay, the time history function, because we are going to use the nonlinear dynamic analysis for time history analysis on this structure, okay. I will use here from file, add new function, okay. I will browse earthquake code, okay. So I will select here Kobe Japan earthquake, okay. So I will view the file. So the header lines to skip 4, okay, and number of points per line will be 5, okay. So, and here the time interval will be this one, okay. So, and it is Kobe Japan earthquake, and afterward I will press OK. Yes, I have defined earthquake records, okay, as a Japan Kobe, and there is no need for this one, and also for this one I will press OK. So I will give us time history analysis for this structure, Afterward, I will just press run analysis. So it is creating and is ready to run the analysis. Okay. Yes, analysis has been completed. Okay, look here. So if you wanna go here for still frame, okay, revise the preference. Okay, like I'm using here 360, this one it is okay, and still moment resisting frame. Okay, so I will come here to start design check. Okay, or otherwise I will come here to the design still frame. Okay, and start design check. It is still checking each and every still members. Okay, and design will be take some time and it will be completed. Okay, design has been completed. Look here, but some members have been filled, some beams. Okay, so like I'm coming here to the plan view. Okay, some beams has been filled. Okay, so I will change it is cross section. Okay, we will change it is reinforcement. Okay, so I will click here. Okay, so I will come here and will select verify all member passed. Okay, 100 still members has been filled. Okay, so the stress capacity check. Okay, I will select all of these. Okay, and I will right click, I will come here. So now the analysis has been completed. Okay, so look here. Yeah, now I will go here, so I can check here the deformed shape. Okay, about earthquake x-axis. Okay, so it is the deformed shape. Okay, so if I just press this side, okay, the deformed shape will be changed about earthquake x-axis, y-axis, and wind. Okay, which have 12 steps. Okay, so if I go here to the member force diagram, I wanna just check it is moment M33. Okay, so apply. Okay, so it is moment M33, and look here to it is shear. Okay, and others like for combo load combination, so you can check it is shear to 2 or moment. Okay, so if I want to go here for it is detailing, I will just press here. We can look here also. Okay, for columns I will come here to check design. So look here. So I will go for detailing. So I will then recommend for reinforcement increment or the cross section change. Okay, so all the informations will be just extracted here. Okay, so now I'm going here, verify all member passed. Okay, it is showing that two still frames filled. Okay, so I will select, okay, two columns has been filled. Okay, so I will right click and will go over rights here, and I will change here the current design sections. Okay, okay, now I'm coming here to the still frame and verify all member passed. Okay, it's showing one still member or frame has been filled. Okay, I will just select that one, this column. I will select and overrides, and I will change here, okay, to the spatial moment resistant frame. Okay, and okay, it's still filled. I will change this cross section. Okay, so okay, okay, it has been passed. I want to just see it is details. We will go here, the still frame design, all the information has been given here. If you want to just export it to the Word document, you will just press this one. Okay, it will be exported there after specifying its location. Okay, so here I do not want to discuss more about result extraction after analysis completion. If you want to see or understand about results in very detailed manner, please look to my previous tutorials, which link is in the description box. Okay, it was all about designing and analysis procedure about steel structure. Thank you so much for watching this tutorial, and do not forget to subscribe this channel. Have a great time.